Blood type antigens can best be imagined as long antennas made of chains of carbohydrate molecules extending outwards from the surface of our cells. When most people think of the term blood group, they most often imagine a type of red blood cell. But our ABO blood group antigens are widely distributed through the tissues and secretions of our bodies, including the taste receptors of the tongue, salivary gland, thyroid, lungs, stomach, intestines, ovaries, and prostate. Virtually every surface where our body comes in contact with the environment contains ABO blood group antigens. Each ABO blood group antigen has a unique chemical structure and differs from the others by a single unique carbohydrate at the end of a long chain. These antigens are also secreted independently in saliva, semen, ovarian fluid, tears, stomach, pancreatic juices, and digestive mucus. In order to best understand the significance of blood groups, we must go back to a distant point in human history, a time long before vaccinations and antibiotics, when your blood type may have been the difference between survival and extinction. Although the mutations that produce the ABO blood groups are ancient, many authorities believe that blood group O possessed a survival advantage over groups A and B due to the fact that it is the only blood type with two blood group antibodies. This may have made group O more resistant to the parasites, flukes, and worms that plagued early humans and probably shortened their life. Although the other blood groups may have been present, until recently they were probably found in only very low numbers. Group O was the numerically dominant blood group at an important time when man began to fashion tools and make his transition from scavenger to hunter-gatherer. In addition, the ability to communicate via spoken word meant that these early humans could hunt in organized packs, giving them access to the previously unavailable protein sources to be found in the abundant large game animals. Microorganisms, including many strains of bacteria and viruses, are often more lethal for one particular ABO blood group over another. This is the result of the microorganism mimicking the human host's blood group antigen and evading detection. For example, bacteria with a surface antigen similar to blood group A substance would be viewed as less foreign by a blood group A's immune system. Many of the great outbreaks of plague and pestilence that decimated the populations of the ancient world in Middle Ages are known to be highly blood group specific. Even to this day, a recent outbreak of cholera in Peru was thought to be highly virulent because of the fact that the population of Peru is over 95% blood group O. The effect of these ABO blood group differences on our ability to resist infection reached its zenith when man began to replace his prior hunter-gathering existence with a farm-based urban existence. Unlike prehistoric times, when the advantage seemed to lie with Group O, these new circumstances appear to favor Group A, who are more resistant to the types of infection that people contract when in dense urban environments. For example, a map detailing the year of appearance and severity of the Black Death Plague correlates with the higher frequencies of blood group A in these same modern populations. With the advantages of modern medicine, the effects of these blood group susceptibilities have largely been eliminated. But one thing will never change. A basic force of nature can always be expected to be applied. It is that all of us will be made slightly different, so that a portion of us manage to survive.